technology sessions. So I am Shripati, working as Aerospace and Defense Industry Head at MSc Software and Hexagon. I'm also a member of Aero Standards 2021. I'm also a member of Aero Forum 2021 and 2022. And then I'm joined with Mr. Satish Shastri. So Satish Shastri is Director and Site Lead, Global Engineering and Technology Center at Collins Aerospace, and organizational head for the entire engineering activities. He's also member of Aero Standards 2021. So we both are hosting track 2 this evening. After a wonderful session by David Alexander, we are kind of starting with exciting sessions which will provide insight into a lot of standardization in both electrification and as well as AI and ML and few other topics. So Satish, would like to know from you how many technical committees maintain SAE Aerospace and Systems Management Standards program right now?
Oh, yeah, that's a good question, Shripati. Well, good evening, everyone. If you attended David's talk, you would have heard him talk about the number of standards that we maintain. Shripati, it's almost 180 technical committees are there under SAE Aerospace Standards Committee, and over 7,600 standards are being maintained, updated, modified under this committee. So, and it covers wide range of domains and disciplines. So it's a very vast wealth of technical standards this committees take care of.
Excellent. I think one of the largest standardization technical committees across the globe, and we have had most of the speakers who are, I would say, stalwarts in this particular industry. Thanks a lot, Satish, for your insight. And I think in next 2 hours, we will learn about initiatives and activities for the committees like SAE E40, G19, A6 and G35. This is the session which covers most of these topics. Let us start with SAE E40, that is electrified propulsion, which is covered by Mr. Richard Embrios. I'm glad to introduce him. He is chair for SAE E40 and he is head of propulsion at Airbus. Richard Embrios graduated in electronics engineering in the previous century. And Richard worked in different positions in different industries, automotive, space, telecommunication, and electronic components. Pretty much, I think, a demography of every engineering concern to the aerospace. In the middle of his career, that is again in the previous century, you could actually imagine the amount of experience he carries. He had worked on PhD with Motorola on power electronic components. At this stage, Richard became able to make a comprehensive link between the physics of material and behavior of a complex system under all foreseeable conditions. So today he is working for Airbus in the at the position of the head of propelling Zero E demonstrator. So Richard became E40 founding chairman of the Electrified Propulsion Committee created in November 2018. Richard had a chance to travel to various continents, discovering different cultures, different way of working. Richard is passionate. He of course loves traveling and is passionate about playing violin, rebuild classic cars, work hard to become a wine specialist, and he is recognized to be a good cook as well. Richard, over to you. I think next few minutes we can actually learn a lot from Richard. Over to you, Richard.
Nice to be with you today. My name is Richard Ambroise, and I'm with you today to present you an overview of our SAE 40 Electrified Propulsion Committee. I will share with you a presentation that is a tool that we had developed and we maintain in our group. It's a communication tool that has been developed to support our ambassador to present the progress where we are in our committee, who we are, what we are doing, and what is our roadmap. So it's why the summary of the title of the presentation is Summary for Ambassador. So the story starts globally in 17 on 18, so 2017, 2018. At this time, I was working on propulsion in Airbus, and at Airbus, it was identified the need to develop the technology on electrified propulsion with to meet the objective of our industry, that is to reduce the carbon footprint of our industry. And it was clear for us that the electrified propulsion technology is an enabler. It was clear for us, it was clear for me, and when I started to work on this topic, based off my experience, my involvement on standardization on engine control at this time, I was working at this time on electronic on engine, so it's mainly engine control for traditional aircraft. I was active member of E36 Engine Control Committee, and it was clear for me that to develop and introduce this new technology, we need to develop standards. So I launched a survey to understand what are the groups available to work with. And the status was clear. There is only 2 days. We had a workshop. And the objective of the workshop was to reply to 2 questions. The first question is, us as an industry, do we need to create a working group to establish a set of standards? And if the reply is yes, the second question is, what should be the roadmap of this standard? So an initial shopping list, so the group replied, yes, we need a working group. The group initiated a first shopping list of standards to be launched with priority ranking in terms of timing. Then we define the scope on the objective of this group. In November 18, the SAE Council accepts the creation of our group. The name of the group became E40, officially E40 Electrified Propulsion Group. And I had announced and presented this group in Europe, in London at SAE ASTC in November 18, and in Asia at Tokyo to the GA 2018 end of November. And what is important to keep in mind is that as the industry considers that this technology can be an enabler to reduce carbon footprints, we propose the E40 as a tool to pave the way of the introduction of this new technology to our future aircraft. Then, another point that is very important for me is, we say the representation of the industry. So which industry is represented by the production of our standards? So we just saw that, large population, large industry. The second aspect is to be able to be legitimate when we produce standard. We need to demonstrate that we have the skill on board on the group in order to produce, to establish the appropriate standard, so the acceptable mean of conformity, the standards that will be able to be eligible for the authority to declare them as acceptable mean of conformity. So this figure represents a survey that we made at the beginning of our history. At this time, we had 123 people on our roster. Now we have more than, we have the double. We have more than 200 people. And you can see that we have in our group all the skill that allow us to say, yes, we are legitimate to produce the standard in terms of representation of the industry, such as in terms of skill. This is to give you an overview of the result of the survey we made at the beginning. The real request from the population is first, so the size of the character is representing the number of replies. The majority of people in our group is looking for standard and guidelines. But you can see that regulation, certification, technology, collaboration, and safety are the second order of priority for the group. Then we had established a list of, that is for our roadmap, what should be the next publication we have to launch. So 11 related to safety and certification, 15 related to system aircraft design operation, and 17 on technical standard. And with this figure, we have the mapping of, in terms of priority, in terms of importance of publication, such as timing. So you can see that what is very important and now is to provide standards that will support the industry in certification consideration and compliance. So you will have the slide available, so you will be able to go in detail on it. So I will not go more in detail. As I said at the beginning, what is very important in our group is the collaboration. So in this group, what I had created is the role of ambassador. We have the role of liaison in our SA committee, but liaison is not the same as ambassador. Ambassador is a strong role. The role of an ambassador is a role of, it's the guy that brings the voice of our group and will ensure, I would like to say, a nice cooperation between others. And in this slide, you can see a large list of groups. And what you can see with under brackets is the name of our ambassador. So all those people are both E40 member and member of the other group. And they have a strong role is to ensure an appropriate relation between our group. And you can see that there are a lot of groups where we need to develop our collaboration. One very important group from my personal point of view is ASTM. I already said that, F39 and F34. And we have Peter Lyon, Mr. Fletcher, and Gary Oran that help us on it. But there are also Gamma, EPIC that is important, and so on and so on and so on. So now I will provide to you an overview of where we are on each development of standard. So I will start with our 8676 ARP. The objective of this document is to reply to a need that we clearly understand at the beginning. Are we sure that with new technology and new architecture, we have the appropriate set of terms to describe what we are doing? First objective. Second objective, are we sure that when we are using a term, are we sure that we have all the same understanding? And the typical word that reflects this question is hybrid. What means hybrid? So On this slide, you can see the scope that we have on our documents. As I just said, the term on description describe will help the people working on this industry to understand themselves. What is very important to keep in mind with these documents is that these documents you will see will be published in the coming weeks, I would like to say. But our industry is at the beginning. So we know that it will be essential for us to maintain these documents. We have the traditional 5-year update process in our SAA, but I don't know when we will update these new documents. I expect to publish these documents this year, but maybe in 6 months, 9 months, 1 year, we will have a novelty in terms of definition that will request us to update again these documents. So these documents, we know that mainly at the beginning, will be updated periodically. This is very important. And these documents is an ARP, not an AR. And we had very, very interesting cooperation with the SAA Council and discussion around that, because for us, it's clear. When we have a definition, in our scope or E40 Electrified Propulsion Committee on Industry, we need to ensure that we will not introduce misunderstanding in our standard. And it is why this document is an IR, but an IRP. And then, okay, I will speak just a few minutes in the next documents. And this document's term and definition is strongly correlated to another document that we have, that is the IR 8678 documents that describe architecture. So architecture description on term, on the terminology, there are 2 documents that are very closely related and will evolve together. In terms of status, so we had started the first BALO in June. Comment has been 100, the order of magnitude of the number of comments, it's 100 comments. We collected, we first circulated the documents in our committee. The first time we collected 300 comments, 300 comments. So we address all the 300 comments, update the documents, launch the BALO, and then we collect something that 100 comments that we address by this summer. And my objective is to launch the second BALO for publication in the coming days. Just what we say, these documents will be updated as soon as we will need to update it. The second documents, the ones that I just referred to just before, that is closely related to 76, and we really intend to publish at the same time, when I say this time, no more than a few weeks, both documents. So these documents is clearly an IR. Why? Because it's not the role of our organization to recommend an architecture. It will be the responsibility of each type certificate owner or the company to define the best architecture for their product. So clearly not an IR. But it was very interesting for us to describe a set of architecture, of various architecture. These documents allow us then to put name on document, to explain some key function, and also very important to identify interface to from electrical electrified propulsion. So two from, so you can see the interface between aircraft and engine, very important. Interface within the electrified propulsion, and address novelty on energy management, storage architecture for electrified propulsion. And one other important topic is that this document architecture will serve as a reference for our activity in various other documents. So when for example, 77 RP 8677 documents will refer to a specific architecture, we refer to the architecture that is described on these documents. In terms of development plan, a first BALO has been launched in July, rejected by only one people, me, because it was clear that we need to synchronize, to refine the coordination between terms. So it's very few modifications to introduce and to change on both sides, 78 and 76. And I'm convinced that we will be able to launch the second BALO in the coming day in order to synchronize the publication of both documents, architecture and definition in the same time frame to make them available at the same time. 7.7, safety configuration for electrified propulsion. At the really beginning of the story, the first day that we discussed all together, it was clear that with the introduction of new architecture and new technology, the way how we establish the safety dossier to demonstrate that the engine will meet the requirements. The method to build the dossier, we consider that may be similar. However, the method how we build the data may be completely different. And the objective of these documents was to describe how the novelty in architecture and technology may impact our traditional safety demonstration activities. So clearly an ARP, what is clear today is that in these documents, we will address the failure mode of electrified propulsion components. It's very important to say electrified propulsion components because the failure mode of a motor used on an aircraft function may be different than the failure mode of an aircraft, a motor used in propulsion. The environments and the functions may have an impact on the failure mode. So on these documents, we will address that. We speak about failure mode, but then we need to speak about the rate of the failure mode. And when we are speaking failure mode on rates, we will explain based on example on architecture described on the previous documents. We will add few words about propagation of the failure, so meaning the impact of the failure at system level. Then we will have a set of words related to the particular risk. Is those new technology and new architecture may introduce new particular risk or may affect the way how we understand and manage the, I would like to say, traditional particular risk. Then, in the same spirit, how the new technology and new architecture may impact the common cause analysis and the understanding of insulation that we have today. Are we sure that with new technology, new architecture, we are not going to violation of common mode, or do we have new opportunity in terms of insulation? And then the other consideration in the same spirit. As I was said just at the introduction, this guidance is a document that may be used. It's the applicant is doing what he wants, may be used to generate input for system and aircraft safety assessment activities. What is behind this sentence? It's why I read word by word. We consider that all the methods that exist today to build an aircraft safety assessment is still valid. Behind this is all the documents built by the group S18, for example. We consider that there is no reason to change this standard or not apply to deploy the standard as it is deployed today. We are speaking about the creation of the data to feed the existing standard. This is very important for us. In terms of schedule, it's a very complex and very ambitious document. Today, the status is to produce a draft end of this year, to have a first BALO, not BALO, but pre-BALO review beginning of next year in order to be able to launch a BALO next year. It's an ambitious plan. We will see if we adhere to this. During the activities on 7.7, it was clear that there is a topic that is important for the industry. When I say important in terms of schedule, meaning that we need it on the coming months. It's all the activities that is done to demonstrate compliance of the engine to endurance certification requirements. At the beginning, so when I say at the beginning, so before we launch these new documents, our objective was to address this topic on the 7.7 documents. But it was clear that the 7.7 documents will not be published rapidly. So then it was decided to remove from the scope of the 7.7 this subject, and we launch a specific document to address this. So this document is ARP 8689. The name is Endurance Test for Aircraft Electrical Engine. The objective of these documents is to propose to the industry and the authorities a method that will allow the authorities to accept the engine in the same spirit that it has been done and it's continue to be done my English is poor, for traditional gas turbine, so Jet A1, I would like to say, or piston engine, endurance test. But what is clear is that the test profile that is defined today on standard for gas turbine engine or piston engine is not at all appropriate for electrified propulsion. So the objective of our working group 8689 is to understand all the failure mode, to understand what will be the condition to activate the failure mode, and to deploy a test profile that will be able to be recognized as appropriate to demonstrate endurance of electrical engine for authorities. So it's a very ambitious document. The the team working on these documents is impressive. I will name people such as Yves Cousineau for Transport Canada, Gary Oran from FA, and a lot of other people on this group. So I'm very proud of this group. It's very, very, very impressive group. With an impressive schedule, our objective is really to have a robust draft of the documents this year in order to initiate a first circulation for comments this year in order to launch our ballot beginning of next year in order to publish the documents next year. So that it's a challenging schedule, but I'm very confident thanks to of the adherence of this schedule, thanks to the engagement of people we have and the skill. It's true for all the other group, but I am personally impressed by this group. So, in terms of the life of the group, our plan is, as I told you, this has been recorded, and when you will hear me, I will be in our animating our September meeting. Our next planned face-to-face meeting, I don't know. We don't know what will be our future thanks to the COVID. But I feel that I expect and I feel that our September meeting will be the last virtual. And I wish that our next meeting will be in Tokyo in March. I don't know, but it's really what I'm pushing for. If I would like to say Japan authorities authorize us to organize that, but also the international condition. If Japan authorities authorize us, but we are not allowed to travel thanks to the condition in our world, in our country, will not be able. But this is really my objective. I really want and push in order that we restart in 2022. One slide to help us to understand how to join us. So the committee is driven by the officer. The secretary of the group is Gabriel Godfrey. The vice chair is Ed Lovelace, and myself as chair. And we have a great support from SAS staff. Thanks to Nicole. I would like to again thanks a lot, Nicole, for your support. Nicole, if you can hear me, thanks for your support in daily supports. If you have any question, if you want to join us, feel free to send an email to Nicole. She will help you by providing information and to welcome you in our group. This is a summary of our standard, but we already discussed that.
Thank you, Richard. Is the way forward. Thanks a lot, excellent insight into this. So let us now move to G19 Electronic Parts Committee. It is my pleasure to introduce Mr. Bill Schofield, Chair SAE G19 component. He's also a component engineer at Boeing. So Bill has been with the Boeing company for about 30 years. Upon graduation from Washington State University, with a degree in electrical engineering. He started his career in 1985 as an electrical component engineer. Bill has supported many programs, including F-22, Teledesic, and ground-based mid-course defense program. In late 2002, and technology and began to support industry activities, including SAE and International Electrotechnical Commission, that is IEC. Bill is currently the chairman of several SAE committees, including SAE G32, and he's also responsible for the publication of JA 7946. It's my pleasure to welcome Bill. Bill, over to you. Bill, would you unmute? I think.
I'm sorry. I guess somebody muted me. I called in on my phone, so I was muted on my phone, and I unmuted that, but I was muted somewhere else. Can you hear me now?
Yeah, we can hear you very loud and clear. Over to you, Bill.
Thank you very much. I was just saying I've been involved in the counterfeit issue, I don't know, for 10, 15 years. I got in on the ground floor. There was a guy named Jack Stradley who first mentioned it back at a DMSMS conference of all places, and it's been growing ever since to the point today where it's a major issue and serious consequences, and the G19 Committee has been writing standards now for a while. Anyway, go ahead, next slide. So today we're going to talk a little bit about the SAE counterfeit mitigation standards, give a quick summary of some of the content of those standards, and discuss a little bit about where these standards are going in the future. Go ahead, next. So in the form of an introduction, the committees that we have at SAE are the G19 committees for EEE component counterfeit mitigations. We've got the G19A, which is a committee set up to talk about test laboratory standards and how we do some counterfeit testing. And finally, the G21 committee, which is kind of the everything else committee. It's the committee that deals with counterfeit mitigation for material with an E, so it covers everything from fluids to materials. With some, like I said, we'll talk about some of the current and future activities and kind of where we're at today. Go ahead, next slide. By the way, if anybody has any questions, feel free to stop me because I'll just ramble on until you hit the brakes. So one of the key reasons why we like to use standards is so we have some consistent and effective processes that are industry-based so that when one company talks to another company, we can talk in a common language and have confidence that the hardware we're exchanging has mitigated the counterfeit risk. We can't stop all counterfeits, so we talk in terms of mitigation to mitigate the risk. And it helps us certainly to detect and avoid using counterfeit parts. Let's see, the SA committees have published or developing somewhere around 35 counterfeit documents. Those aren't all standards. There's some ARPs and some various other documents that we've been creating. So there's a whole suite of SAE anti-counterfeiting documents. These documents are primarily used in aerospace and defense, but there are many other industries that are also involved with this. Nuclear industry and the telecommunications industry and the power industries, et cetera, are all participants, if at lower levels and less need. Go ahead, next slide. So I think we kind of talked about this a little bit. The three main technical committees are the G19, G19A, and G21. Each committee has multiple documents. per SAE rules, all committees are voluntary. You're volunteering your time. We have a lot of participation from not just industry, but also government and academia. So we get a broad swath of opinions and visions. They're all consensus standards, and we get together on a regular basis also to exchange information about where we see the counterfeit threat coming from and various ways to mitigate it. Next slide. So in the G19 committee, we focus on EEE components. Jim Kryman it's his turn to be chairman of this committee. He's doing an excellent job. As a matter of fact, I borrowed these charts from Jim. He presented them earlier at a CalC conference back in Washington, D.C. earlier this year. We kind of break it up into kind of three key areas that we focus on. We have the franchise distributors. That's the distributors that are authorized by the manufacturers of the parts. Aero and Avnet are a couple of the biggest ones, at least here in the States. That we have a standard that we've written for them that's AS 6496, and it has details about. I think it's primarily focused kind of on traceability and ensuring that the parts that work as they work through the distribution chain are segregated and maintained. And then we have a standard for what we call independent distributors. These are the distributors that go off and buy parts on the open market and then provide them back into our industries. That standard is AS 6081. It's currently going through a revision, and there's always a little push and pull with that particular standard between what the distributors want and the aerospace or the industry needs. So we're actively working on that standard as we speak. For folks that procure EEE parts, that's either whether they're buying them from independent distributors or franchise distributors, we have a standard AS 5553. It's probably the most popular standard in our counterfeit portfolio. That is the standard that the industry has broadly adopted to address the risks associated with counterfeits. We have a verification standard that we've had with it that builds on what we call a verification matrix. It kind of takes every shell statement that's in the document and documents what's expected of it. And I failed to mention it, but we also have a verification document also for the 6081 standard. We have a fair amount of guidance documents, a couple of ARPs. We also have what we have as an AIR document. It's a definitions document to make sure, I heard it mentioned earlier under the electric propulsion, but it's critically important that everybody uses the same language and has the same meanings for the words. So we have that document where we maintain all of our definitions. Okay, next. Some key elements of 5553 Rev C, which is the current revision. It essentially deals with the avoidance, detection, you can read detection, mitigation, and disposition of what we call suspect counterfeit parts. The reason why we use the term suspect counterfeit parts is because only the manufacturer can actually confirm that whether these parts are counterfeit or not, whether they made the part. And the manufacturers don't always get involved. So oftentimes we stop at the level where we find a part that we say, hey, there's a significant amount of evidence that this part may be counterfeit. So we call it a suspect counterfeit part. The AS 5553 is the most popular SAE counterfeit mitigation standard. I kind of mentioned that. The Rev C was published in March of 2019. I'm not sure what 9 pages is a critical piece of it, but it's, we try to keep the standard concise and short and focused on what the requirements are and leave all of the guidance and various elements along those lines to the other documents. The key requirement is for a control plan. That control plan has to address training, life cycle. You can see the various elements that are in there. A big one is the traceability piece on that and the material control. There's always been a lot of hand-wringing over reporting, so we have a reporting requirement. And auditing or verification are kind of used interchangeable, and that's another element of the standard going forward. Next slide. Here we go. We're talking about the 6496, which is the standard for franchised distributors. It has again, its elements are different than they are 55, 53, and you can see that there in that kind of bottom right-hand matrix where we talk. It's focused on their policies and the distribution agreements, like I said, traceability elements, and how they handle customer returns. One of the things that there's always a big concern with is if somebody buys a part and the franchise distributor accepts a return, how do they verify that the part that's being returned is a legitimate part that they shipped originally versus a part that may have, have the same part number on it but been returned some type of a counterfeit part. So there's those are all key elements of the 6496. Most of the authorized distributors meet these requirements. They don't all have a control plan that's been specifically written for 6496. The standard's getting a little long in the tooth, but it's still a standard that we see as accurate and helping the industry. And it was published back in 2014, so you can see it's about 7 years old now. Next. 6081. This is the standard that we're working on, actively working on a revision right now. And it's a little contentious. You can see this standard is 47 pages long, so that gives you kind of an idea of everything everybody's kind of trying to stuff in there, and there's lots of different views on how you and what a independent distributor can do to mitigate the risks of counterfeit parts. So you can see some of the key areas over there is this customer contract and PO requirements, preservation of product, etc. The inspection and test piece has been a big discussion point. 5553 requires mitigation associated with risk. It's hard for the independent distributors to quantify, let alone mitigate that risk. So their inspection and test requirements tend to be a little bit different and harder to standardize on. So there's a big effort in that area. Go ahead, next slide. So here's some of our various ARPs that we have in there. These are guidance documents. They're used across the spectrum. So the first one is ARP 6178. It's a guidance on how to assess a supplier's ability to deal with counterfeits. It's essentially a verification document that has the details on how you evaluate the shells. That document, I suspect, is going to be going away. It's being integrated into a current revision of 5553, so it'll be an appendix in 5553 rather than a standalone. The ARP that gets a lot more attention is this ARP 6328. It takes AS 5553, which is, like I said earlier, a short requirements-based consensus document, and tries to put in a lot of that tutorial and examples, et cetera, of how you could develop and execute a 5553 control plan. So that ARP is pretty active and gets used across the board. And finally, this AIR 6273, that again is the terms and definitions to make sure that our three main anti-counterfeiting committees can speak the same language and communicate with each other, and we know precisely what we're saying when we use some of the terms common in the counterfeit world. Next slide. So here is a quick look at the G19 a portfolio for testing. And you can see all, I'm not going to go through each and every one of those, but they have slash sheets, as they call them, /7s for electrical tests, et cetera. Those are all the various test methods that can be used to identify a suspect counterfeit part. We find this document very useful when we're doing our 5553 mitigation piece, right? So we can call out these various tests or all of these tests dependent on the risk of that part in its application. So if we're building a coffee pot, we may not do a whole lot more than like external inspections. But if it's going into a flight control computer where the consequence of failure is much more significant, then we have all of these other test methods at our disposal to use to evaluate that part before we accept it and install it into our hardware. Next slide. So I'm not going to go through this whole list either. It's a little bit of an eye chart, but you can see that they are actively updating some of the current test methods and developing new test methods as well. As you can see there's a lot of work going on in this committee, and it's moving forward at a pretty good pace. This is a very useful. This committee produces very useful documents, and like I said, in that realm of how do you mitigate the risks and what kinds of tests do you need to run to address those risks. Next. So here we go. The G21, like I mentioned before, it's the Counterfeit Material Committee, and you can see that they have all kinds of different elements within their purview. They've got everything from refrigerants to fasteners to batteries. So again, they're an active committee. They have a hard time staying ahead of everything because it seems like lately everything is being counterfeited somewhere, and writing a standard to address everything is probably not the direct route to go, but we make an attempt at the stuff where we see the biggest issues at. You can see there's some in work right now with the bearings and the batteries. I think that I heard yesterday the bearing standard is getting a little closer to being validated, so it's probably the next one out to join the other 3 or 4 of them that they have already published. Next. This covers everything other than EEE parts. It's first published about 7 years ago in 2014. And this document, they took a little different approach than we did in 5553. You can see it's 38 pages long, but 26 of those pages are guidance. So where in 5553 we have the ARP where we pulled all the guidance out of the requirements document and put it into an ARP, this committee chose to leave all of their guidance in the form of appendices in their base standard. It's 2 different ways of dealing with the same issue. Next. Again, here's a quick slide to kind of take a look at the different kinds of requirements in each of our 4 main standards. This is kind of useful if you're new to the counterfeit issue and you want to see how to address it. The thing to remember that's not in this chart is 5553 is for EEE components, 6496 is for authorized distributors, 6081 is the unauthorized distributors, and the 6174 is for anything other than a EEE part, everything else. All right, next. So where are we at today? So the G19 committee has been consolidated. So we've moved all of the authorized distributors and independent distributors were separate committees. They're all now part of a restructured single committee, G19. Like I mentioned, Jim Kryman is the current chairman of that document. We did that to kind of improve some consistencies between the documents and address some of our member representation voting issues associated with those. And you can see down below, here's a quick look of some of the standards that are currently in work. There's a AS 5553, Rev D is in work. There's that a verification manual for 5553D that used to be AS 6462. That's being brought into 5553 directly as a appendix, trying to keep the verification elements and the requirements elements more in lockstep. We've got the guidance document that is being updated to reflect the changes in 5553. And like I said earlier, we have the bearings and the batteries, some detection testing, and the 6081 for independent distributors. So we've got a lot of work going on currently in the G19 and G21 committees. This didn't talk about, maybe the next slide. Let's go ahead to the next slide. I don't know if we go off to G19A. You can see we're updating the ARPs, et cetera. 6164 is going to go into stabilization. I don't think they want to do a lot of new updates to that one. So that's some G21 work, G19. This is what we're doing in the near future. I think we've talked about most all of these documents already. So that's just a summary slide. Go ahead, next. So in conclusion, we do have our committees are active. We've got participation again, broad participation from industry, government, academia. We have, we address EEE parts, materials, and then testing. 25 published documents, a few more in development, and there's lots of opportunities for anyone that would like to join and contribute to our various efforts here in the counterfeit world. And I believe that's the last slide. Is it? Yeah, that was it. Does anybody have any questions before I leave?
We have questions from a couple of team members here. Firstly, I think there is a question from Mr. Karthi. Counterfeit avoidance accreditation program or compliance to AS 6496 6081 are mandated and flowed on by any ASD or OEM. Any ASD OEM is what is the question from him. And the same person has the question on, I think Mr. Balaji has a question on how to identify if there is a part which is counterfeit. And Mr. Karthi has a question again on are these standards what is mentioned are certifiable by a third party or guidance standards? So these are the questions.
So which standards? Okay, what was the first question again? We got to take them one at a time.
So that is counterfeit avoidance accreditation program or compliance to the standards like AS 6496, AS 6081, etc. are mandated or flowed on by any ASD OEM is the question.
Yes. I can't identify all of them. It's a complicated issue. 5553, I'll talk first. That standard was revised in Rev C to align with the U.S. DoD DFAR requirements. So oftentimes industry uses that to show compliance to the DFAR procurement requirements. In addition to that, Boeing has a baseline requirement for all of its suppliers that deliver integrated electronics of any type. So 5553 is flowed through as a baseline Boeing requirement. There's some IEC standards that are parallel to these standards that are oftentimes referenced, I believe, by Airbus. So these standards are broadly, particularly the 5553 and the systems counterfeiting one, are broadly distributed across or required across the industry. Now, as far as the 6496 for authorized distributors, we don't see that as often as a direct call out, but we do know that the authorized distribution chain uses that standard as they develop some of their processes, and particularly with their return requirements. They've changed their return requirements significantly from what they were. So when they accept a returned part, they usually segregate it. Oftentimes they even scrap it. So it's the returns process has changed greatly. With regards to the independent distributors in 6081, again, it's one of those standards that's used. 5553 requires you can have some approved independent distributors, and most of the OEMs are using that standard to approve their distributors, even if they're not calling it out directly in contracts. So that's the application piece and how that's been implemented across the industry. No one knows the second question?
Yeah, I think the second question is how to identify a part being counterfeit. That is the question.
How do you identify a counterfeit part?
Yeah. So it's actually very difficult to find the counterfeit. Hence, now Mr. Khan, this question is by Mr. Balaji Birur, and
Yeah.
I think over to you, Bill. Very complicated question.
It is a very complicated question. So originally, back when I first got started with this, it was as simple as looking at the marking and seeing if the marking was professional. I'll call it a professional marking, or looked like the marking was applied by an OEM. The counterfeiters have gotten much better over the years. And oftentimes you can't even tell a counterfeit if you do electrical tests. So that's when you see that suite of testing that's listed associated with that G19 committee. You do those tests, and it can give you an indication on whether a part is counterfeit or not. But obviously those tests are costly and require large sample size, et cetera. So we oftentimes talk in terms of risk. So how much testing do you do to identify a counterfeit part to mitigate the risk where that part is going to be used? So it's a very complicated answer to what seems like a very simple question. There's no easy way to tell if a part's counterfeit anymore.
One of the books which I have gone through, it's a fictional book by Michael Crichton. I think Airframe, all the aerospace enthusiasts would have read. I think mention on counterfeit being better than to find out whether it's counterfeit or not was a main issue. I think that is something which comes in here. Thanks a lot for your insight, Bill. And we also have Mr. Karthi asking, is these standards which are there are certifiable by a third party or guidance standards, or how is it? I mean, that is something which is there from him.
Yes, there are third parties out there that will certify to them. PRI is probably the largest organization that certifies to 5553. The IECQ, for those of you that are familiar with the IEC world, the IECQ also has some third-party verification schemes for counterfeit. The issue is that very few OEMs currently require the third-party certificate. So typically the OEMs are managing those verifications on their own rather than going to the third parties, at least at this point. But the third-party certification process is set up, and we've been working with it to verify it when we can.
Okay, so I think your inputs are very encouraging here, Bill. And I think to all the audience, we are running short of time, and we would wish to have much more detailed discussion with the team here. So I will be kind of moving on further with the proceedings, and we'll take these questions, and then we'll have a session with the answers to you over email on your clarifications. I think
very good. Thank you.
Thanks a lot. Thanks a lot for wonderful presentation and insight, Bill. So over to the next presentation. So I would like to invite Mr. Ian Halley. Mr. Ian Halley will talk about aerospace actuation, control, and fluid power systems. So Ian Halley is chair of SAE A6 and technical fellow at Boeing. So he's a Boeing technical fellow specialized design and analysis of flight control and vehicle management systems. Ian was past chairman of SAE A6 A3, Flight Control and Vehicle Management Systems Committee, and he's currently serving as committee chairman for SAE A6 Actuation, Control and Fluid Power Systems Committee. Ian is a private pilot and holds a BMSc from the University of Illinois, and he's a MEM from Washington University and MSSE from Missouri University of Science and Technology. Ian Halley, over to you for a presentation on standardization on these particular topics. Thank you.
Thank you very much. I guess a quick sound check. Can you hear me all right?
We can hear you very clearly.
Okay, good. So I'm going to provide a quick introduction to the SAE A6 Committee, which is the Actuation Control and Fluid Power Systems Committee, which I've had the pleasure of chairing for the past 6 years. Next chart. So this SAE A6 Committee is a standards development organization to promote the advancement of actuation control and fluid power in support of aerospace vehicles. And it was founded in 1941 and has continuously evolved to adapt to the new trends and technologies that we see actuation control and fluid power. I thought I'd go through a little bit of the history just to show the evolution of A6 over the years. Next chart. So as I mentioned, the SAE was one of the oldest SAE aerospace committees, founded in 1941. Prior to that time, hydraulic systems had really been used just for brakes and landing gear operation in aircraft. Although I think as early as 1934, the DC-3 had hydraulic power wing flaps. But in the 40s, we started to see hydraulics used for primary flight controls on the P-80 and the Lockheed Constellation. And as such, there was a desire to get a group of experts together to talk about issues that they were starting to see with leakage, contamination, and failures. So the first industry team of individuals was created, and they would develop issue papers, procedures, and standards. In our membership, our first chairman, actually, Harold Adams, who was chairman from 1941 to 42, published one of the first books on aircraft hydraulics that was dedicated to that subject. And I guess of note, another one of our members, longtime contributors, Dave Brent, developed the hydraulic system for the Spruce Goose and was actually sitting in the right seat next to Hewitt when they went on their one and only flight. Next. The 1950s saw the increase of hydraulic system pressures from around 1,500 to 3,000 psi. Also developed the MLH 5606 fluid, and there was the standardization of O-rings and squeeze levels, in addition to increased temperature range, filtration, classifications, and levels are defined. And then A6 was also rescoped to also have the addition of missile hydraulic and pneumatic systems. Also of note, one of our longtime contributors, George Keller, published Aircraft Hydraulic Design, which some of you may have in your libraries, and I go to that one occasionally myself. Next. In the 1960s, we started to get into variable delivery hydraulic pump development, specification, storage considerations for missiles, thrust vectoring, and then there was another restructure of the A6 committee to emphasize new technologies, including the electromechanical actuation, fly-by-wire hydraulic or actuation systems, and then the fluidics and non-moving hydraulic components. We added marine and underwater applications and also started to look into commercial aircraft hydraulic systems. Also of note, our longtime chairman, Bob Turee, served for a quarter of a century at this time. He's our longest running chairman and probably will be the longest ever. So we try to limit terms to about 3 years now. But he served for a total of 27 years as our chairman. Next. The 70s saw development of the phosphate ester fluid specification for commercial aircraft. There was a lot of work with integrated actuator packages and additional hydraulic specifications for military aircraft. The U.S. Navy kicked off a study to evaluate different system pressures, kind of focusing on 8,000 PSI. And then we also started to focus on flight control actuation redundancy, commercial aircraft system, aircraft hydraulic system problems. And then we also aligned better with the ISO organization. And again, our longtime member George Keller published hydraulic system analysis, which I think is still used by quite a few engineers. Next chart, please. 1980 saw a move to direct drive servo valves in military hydraulic actuation applications. There was a lot of work with 8,000 PSI that continued in non-flammable fluid development. Work and emphasis on lightweight hydraulic system design concepts. 7A6 started a lesson learned symposium, which we've continued through to this time. A lot of the research and development on the 8,000 PSI and the lightweight or the non-flammable hydraulic fluid was done by some of our members and their teams at BINS, at Snyder and Neil Pierce were there people really leading that development at the time. Next chart. So the 1990s, we had a lot of military specs that were transferred to SAE for maintenance. So we took those in. A big focus on seal leakage prevention. Electrohydrostatic actuators started to pick up speed. And then we also did some consulting with government agencies. And one of our past chairmen, Kurt Chenoweth, published flight control actuation. Some of you may have seen. And then another longtime contributor, Bernard Schmidt, published a book called Fly by Wire. So a lot of books being written by members of our committee. Next chart. So the 2000s, we started to have more emphasis on unmanned aircraft and the actuation for those aircraft, increase in more electric aircraft. Again, more development in electrohydrostatic actuator and electromechanical actuator documents. We also started to develop standards for pilot interfaces, such as active sticks and passive sticks and pedals. We really committed to SAE globalization, and we held our first meeting outside of North America in Toulouse, France during the 2000s. Members of note, our second longest serving chairman, Luther Smith, was rewarded the Congressional Gold Medal. Luther was a World War II hero and was a pilot with the Tuskegee Airmen. And I had the pleasure of meeting him. He was a very sharp individual and sat in our meetings and provided a lot of insight into his areas of expertise. Next chart, please. In the 2010s, we had a move in the military to bring in more flight essential, flight critical equipment control into the flight control computers. So those were termed the vehicle management systems. We have a generation and distribution of electric power that kind of allowed the move to more electric aircraft. We have more requests for hydraulic power packages. And then within the committee itself, we added working groups to the agenda and worked to streamline the voting to reduce the time it took for us to produce our documents. We have an increased focus on lessons learned and document quality to improve our standards. We added short courses to share some of the expertise that we had within the committee to new members. We also continued to visit international venues to attract new members. Next chart, please. And just thought I'd quickly show our name evolution. As you can see, it started out as aircraft standardization, being one of the earliest committees devoted to aircraft. And then quickly was rebranded as hydraulic and pneumatic equipment. And then in the 60s, we added the control technologies. And in the 80s, we added the actuation focus. And since 2001, we've been known as the Aerospace Actuation Control and Fluid Power Systems Committee. Next chart. So where are we in 2021? We invite you all to be part of the 2020s with us. We are the leading standards body in actuation control of fluid power, and contributed to the growth and quality of those technologies since our founding. Currently, we maintain about 270 documents, including 70 aerospace standards, about 100 recommended practices, and 85 information reports, as well as some aerospace materials standards. So quite a few documents are maintained within A6. Next chart. So we generally hold two meetings that are generally in North America. We've been trying to go overseas to an international venue every 4 to 5 years. Meetings are used to debate, evaluate, and recommend solutions to various products and the problems we have within the aerospace community. Meetings typically have about 150 to 200 participants. Again, we have our short courses that are offered. We have lessons learned that are offered as part of the meeting, and these are very important to us. We've had over 200 lessons learned brought forward as we put focus on that topic. And we have a document that we published that captures all of these lessons learned. And then also a lot of these lessons learned will make their way into our standards and recommended practices. Another thing we do to aid our development of documents is we have themed symposiums that are organized at every meeting, and it's always focus on a particular technology interest to our members. Sometimes we use these symposiums to kick off a new project, or if we see that there's a technology that's starting to come of interest to our members, we'll have a symposium to focus on that topic, and then we may start a project to standardize or provide information about that new technology. Next chart. So within the Aerospace Council, you may or may not be aware, there's a number of divisions. A6 resides in the Mechanical and Fluid Systems Division. I've got it boxed there in the blue box. I've highlighted committees that are located within Aerospace Council that we have frequent collaboration with. And as you expect, landing gear systems is one. And as we go more electric, we've been doing one with the AE7, which is the Aerospace Electric Power and Equipment. But also quite a few of these other committees we have regular correspondence and collaboration with. You'll see the dashed box around AMSCE, which is the Elastomers Committee, and AMSP, which is the Polymer Materials Committee. Those two committees meet with A6 wherever we meet, so they're always meeting in conjunction with us. So, if you come to an A6 meeting, you also have the ability to go to these elastomer meetings or material meetings. Next chart. So A6 is maybe organized a little differently than a lot of SAE committees, in that A6 is a committee that encompasses several committees. A6 has documents that it's responsible for. As I noted, I'm the current chair for SAE A6. I have a steering council that consists of about a half a dozen individuals that have various responsibilities to help SAE A6 function. 3 of the members of the steering council are the leaders of what we call our subcommittees. We have 3 subcommittees. A6A is the System and Subsystem Integration Subcommittee. A6B is the Actuation and Control Subcommittee, and A6C is the Power Generation and Distribution. Within A6A, we have a committee devoted to commercial aircraft, one devoted to military aircraft, and one devoted to flight control and vehicle management systems. Within A6B, we have the various actuation technologies that we focus on, with A6B1 being the hydraulic servo actuation, and they have all the documents for electrohydraulic servo valves, the direct drive valves. A6B2 is the electrohydrostatic actuation committee, and then A6B3 handles the electromechanical actuation. And then A6C is kind of all the components that are needed to generate and distribute hydraulic power. Go through a few of the documents of note to these committees. Next chart. So A6 itself has kind of the general interest documents. So there we have an ARP that has all the terminology and definitions related to actuation, control, and fluid power. One of our most popular documents is AS 1290, which has all the graphic symbols for hydraulic and pneumatic systems defined. They also have our lessons learned document, and we hope the impulse testing, just because that's of interest to most of our committees at the A6 level. Next chart. So A6A, we have some of the military standards here that A6 maintains. AS 94900 is the old MLF 9490, which is the general specification for military piloted vehicle flight control systems. A6 has written A6A3 has written a companion to that document, ARP 94910, which is devoted to military unmanned aircraft. We also have the old MIL-H 5440, which is the hydraulic system specification of military aircraft, and the general components specification 8775. We did take that 8775 and developed a standard for commercial aircraft that is kind of the commercial aircraft equivalent. That's AS 4941. And then recently, as I mentioned, we've started to have standards for active inceptors and passive side stick control and integrated rudder and brake pedal units. And then lastly, the one I wanted to highlight was ARP 5770, which is the mechanical control system design guide. Next chart. So this A6B is the actuation control. So the first three items listed there are the standards that most of you would be familiar with who are into hydraulic actuation. So for the hydraulic actuators, the next one is a newer document that's a guideline for motor control electronics for electrical power actuation that just completed. Then we have the recommended practices for electromechanical actuators and for electrohydrostatic actuators. Next chart. And then A6C are where most of our documents reside, so I just wanted to highlight a few of them. The contamination and filtration, of course, has the classification for contamination and means of counting and assessing contamination. A6C2, by far, are most documents maintained there. We have over 90 documents related to various seal technologies that reside there. A6C3 is the fluids. That's where the phosphate ester fluid specification resides. And we also have an AIR that's very useful, that it contains information about the various physical properties of hydraulic fluids. Next chart. In the power sources, A6C4, we have basically all the specifications and recommendations related to power, pumping, accumulators, motors, and hydraulic starter pumps. And then A6C5 has our general components. So those are things like solenoids, hydraulic fuses, and system reservoirs. So it's a kind of a quick summary of the work we do in SAE-A6. We have a meeting coming up next month. It's going to be virtual, hopefully our last virtual meeting. To join that. Any questions?
Any questions from the audience? You can put in the chat box. Ian, thanks a lot for your insightful session on SAE ASICs activities. I think we have, that's not a question. We will have the next speaker. We will have him shortly online. There's a technical problem at the end. I think any other questions in general to the team, to the speakers, including Ian right now, would like to maybe invite anybody to ask any questions on the chat box. Please drop your questions.
Hi, Mr. Sripati, Suraj here. I think Dr. Andreas is
Join?
Yeah, he's joined.
Great. So let us move to G35, that is Modeling, Simulation and Training Committee talk. So we have Dr. Andreas Quaiger who will talk about G35 modeling, G35 Modeling, Simulation and Training Committee. So I would like to introduce Dr. Andreas. He is a system architect at Airbus Defence and Space GmbH, Germany, with a track record of about 13 years of professional experience in the aerospace domain. He's leading several research and technology projects in cooperation with universities and research institutes in the areas of software engineering, software quality, systems engineering, cybersecurity for avionics, etc. So Mr. Quaiger shares his expertise as leadership member of SAE International G32, which is Cyber Physical System Security, and SAE International G35, which is on modeling, simulation, and training for new emerging technologies and concepts. In addition, he is committee member of SAE International G34, that is on artificial intelligence in aviation, and also SAE International E36, that is for electronic engine controls committee, and SAE International S18, which is aircraft and systems development and safety assessment committee. Latest research results are developed and communicated by him through teaching regularly in university lectures. Mr. Quaiger advances research by having initiated the scientific workshop on avionics systems and software engineering, where he's part of the program committee. So furthermore, he supports the scientific workshop on open model based engineering environment, that is Open MBEE, as a program committee member. So he has been awarded diploma and PhD in computer science by Technical University of Munich, Germany. Dr. Andreas, over to you for a nice session.
Okay, ladies and gentlemen, thank you very much for this kind introduction. Before I'm getting started, do you hear me?
Yeah, yes, Dr. Andreas.
Okay, very good, very good. So, all right, as already mentioned, I am going to introduce the G35 committee, which is really brand new because we didn't officially have our kickoff meeting yet. The kickoff meeting is supposed to take part next week on Monday. So everybody of you is also invited to join us if you would like to do so. So you can find out about the meeting details and the WebEx information. Just going to the SAE website and look for the G35 committee. Right, you should now be able to see my screen, and I will be starting to share really a very rough overview of our committee. As I mentioned already, we have not really started yet, so we are just amongst the kickoff phase while we have got the meeting, the first meeting next week. During this talk, I would like to introduce a little bit of what we are doing, of what we are planning to do, and who the leadership persons are, and finally, why is the need to come up with a new committee. So the committee leadership is formed by people coming from several domains. I've got the pleasure to lead to be the co-chair of this committee together with Marilyn Pearson. I'm really happy to have her around. She has got a very, very long track record as a pilot. So she is coming from the user domain of a future aircraft. This is really of utmost importance because as I was introduced before I started this presentation, it was mentioned that I have got a background as a computer scientist, so I'm a pure engineer. And though I'm working for Airbus Defence and Space for around about 13 years already, I do not have a pilot license or anything like that. So I know, of course, how to develop an aircraft, how to do this according to processes in order to get the type certification after the end of the development process. However, it is of utmost importance to include the operator view as well. And therefore, it's really an honor for me to have Marilyn Pearson aboard as well. Next to both of us, we have got around Martin Field. He is also an engineer having a track record of 30 years professional experience, and he's also an engineer. So he is also part of the leadership group. Apart from him, we have got Ravi Rajamani around. He's working as an independent consultant and is has got very strong background, has got a very strong academic background. This is also what we need because we want to gather people coming from as much as possible domains to make sure that we cover all that we have to take into account during the course of our committee. Now, apart from that, we have got, of course, we have got also a secretary on board. Unfortunately, we are still in the process of compiling all the slides, so therefore I needed to skip some of the other persons who are part of the leadership team. However, I've mentioned the most important ones. So what do we want to do in our committee? So we have got, as demonstrated here on this slide, we have got many different committees already existing, and they are focusing on various aspects. For example, systems engineering, artificial intelligence, and so on and so forth. On top of that, we have got many different domains, such as already mentioned, like flying crew members, the aviators, and the academic, and also the huge manufacturers like Boeing, but also some smaller manufacturers, which we need to take into account when talking about new aircraft types like urban, like the ones which will be available in the context of urban air mobility. So apart from that, we also, after having developed our aircraft, we also have to make sure that we train the flying crew. And for this purpose, we need to take into account the simulation capabilities. That means that we have to take aboard the companies which are developing training facilities for the flying crew. The yellow yellow marking might not be readable. It says software developers. Of course, nowadays everyone is talking about digitalization, and this is what you have to take into account as well. So we have to cover all those areas, And we have found out that there is no committee around yet which covers all of this, and therefore our objectives is to bring together all of these domains, persons, and also tie together already existing SAE committees, like for example G34 on artificial intelligence, but also on systems engineering. I think that should be S18, and various other committees which are relevant. So our mission is to make sure that we do not duplicate our effort, but use already existing work. And for this purpose, it is very useful that I am involved in several other committees, which helps me to find out what's going on in these committees and make sure that we tie all of this together in our G35 committee. Now, we would like to bring all of this together. We are expecting new types of aircraft in the context of urban air mobility. And these are supposed to be smaller aircraft, probably electrically powered, and also hopefully autonomously flying. And therefore, we have to take into account several issues, like what do we need to do in order to have such types of aircraft certified by the authorities like the EASA and also the FAA. Of course, we have to take into account emerging technology. Of course, AI is the most relevant if we are talking about autonomous flying. However, we are not dealing with AI on its own, but rather would see it or perceive it as a tool in order to come up with autonomous flying. For training the crews, we need to consider virtual reality, mixed reality, or augmented reality. And for the development purposes, for speeding up the development, we need to consider digital twins to make sure that we can develop the aircraft faster than it is done today. In order to do autonomous flying, we want to resort to artificial intelligence, and artificial intelligence itself is in the need of lots of data for training purposes. For example, let's consider a very simple example. Such an autonomously flying aircraft is supposed to fly from position A to position B, and in order to get from A to B, it has to fly autonomously. And this means it even if we assume that the flying path is already predetermined, we still have to consider any unexpected obstacles in this flight path. Therefore, we need to make sure that such an autonomously flying aircraft is able to sense obstacles, and in the second step, to avoid these obstacles, i.e. the vehicle needs to come up with a maneuver which allows it to circle around the obstacle. And therefore, we have to take into account the domain big data as well. So what we are going to do is we need to pull in the results of the other committees, in particular G34 on artificial intelligence, and have to find out how we can use this technology in order to enhance both the training for the flying crew, but also the training of the AI built in the aircraft itself. And this is what all the aspects that I have mentioned up to now are depicted on the left-hand side of this slide. And all of this needs to be put together to come up with a consolidated standard document. So this is what our objective is going to be. And here are some, on this slide, we mentioned some starting points. As already mentioned, we are right at the very beginning of our committee, so therefore I cannot talk about any attendee numbers or the number of meetings that we had and the number of pages of standard documents that we have already created. So this is more or less a teaser of what's coming next. So we would like to use modeling and simulation to support the certification and also the credit for aircraft and training for the pilot and aviator. So it's always several aspects that we have to take into account. We have to take into account the authorities for certifying the aircraft itself, but also we would like to develop methods for training the flying crew. And of course, this has to follow certain standards. And this is exactly the place where I'm really happy to have Marilyn Pearson around as a former pilot. So she has got a lot of experience and she knows exactly how such a type certification for a flying crew needs to take into account. Now, as already mentioned, we would like to have a look at digital twins. How do we want to use them? We want to compile guidelines on how to use these digital twins and also virtualization technologies. And we want to use this for the phases development, verification, and finally validation, where we do the integration of the complete virtual aircraft. And of course, I was already talking about the flying crew training. We need to create consensus standards for flight simulation training devices, i.e. the training devices that are used for training the pilots. All right, and up to now, pilots were used to flying classical aircraft. They were the persons in control of the aircraft. If we look a little bit further in the future, the control of aircraft, in particular new types of aircraft, will change considerably because we have got artificial intelligence around. Artificial intelligence is supposed to work not only, for example, for object recognition and warn the crew because of an obstacle, but we expect that the aircraft is doing adequate reactions after having detected some obstacles. And this in turn brings us to a completely new human-machine interface of the pilot for the autonomously flying aircraft. When I'm talking about the pilot, this doesn't necessarily mean that the pilot is sitting in the aircraft, but we assume that at least for the starting phase of urban air mobility, that we have got a pilot sitting in some ground station and controlling and supervising the autonomously flying aircraft. But even then, the pilots in the ground stations need to be trained such that they are capable with the new human-machine interface, which will be driven in future by artificial intelligence. And thus the role of the pilots will change considerably. As I said, nowadays they are in complete control of the aircraft, and in future the aircraft, it depends a little bit on the level of autonomy that we are going to allow. But if we are allowing a lot of autonomy, then the aircraft will do maneuvers on its own, and the pilot is more or less supervising or monitoring the actions of the aircraft. Nowadays, it's completely it's the opposite. So this is what we have got in our mind that we would like to do. What's coming next? As I mentioned, we are at the very beginning of our committee. The kickoff meeting is next week on Monday, and the first step is we need to find good enough participants with good enough expertise who are also willing to contribute to several standard documents, which I have kind of outlined, and therefore we need lots of volunteers. And this is also an invitation to this audience. So if you are interested in joining our committee, you could get in touch with the organizer of this event, who will certainly have got the contact details for me, and I'm happy to put all the interested people on the roster to make sure that all of you are involved in the new committee. And there is also the chance, if you are missing, for example, the kickoff meeting next Monday, you have got always the chance to join, even if we have already started. So you don't have to worry. You can also reach out to any of your colleagues and invite them. Anybody is really very welcome. And it will be, yes, quite a lot of fun, because from my experience of other committees which I am leading, it's really awesome to work with volunteers. It's nobody of us is told by our bosses of our day jobs that we are supposed to do this. It's our own decision, and it's really a pleasure to work with volunteers. Now, the set of topics that we need to cover is really pretty huge. So there is a lot of new technology already in our minds, like artificial intelligence, and we expect even additional technologies to come up in the next few months and years. And therefore we expect that we need to split up our committee into several subgroups. And therefore, this is also something that we are going in our kickoff meeting. We are suggesting several subgroups that we suppose we need. And it might turn out during the course of our committee that we need some additional subgroups. So it will be pretty dynamic. Then the next major action will be the development of roadmaps for what standards might be needed to support our objectives. Of course, such a roadmap has usually several phases, like immediate term, mid-term, and long-term phase. And of course, as we are in the starting phase, we don't have a fixed cadence yet. This is what we have to find out. It may vary over time, and it is dependent on the speed of our progress. All right, I think this is the final slide that I wanted to share with you today. So unfortunately, I couldn't present any detailed technical results yet. The reason being pretty simple. We are at the very beginning of our committee, so we have got some objectives. I told you which kinds of domains we need to include. This is our clear vision, and finally, I've outlined a few ideas of what's coming next. Again, we welcome any participants, any newcomers. Anybody is really welcome. So please spread the news to your colleagues and invite them and tell them it will be quite fun to work in this committee with a lot of people coming from many different domains and having a clear objectives and taking into account the cutting edge technology for making flying for us, for all of us, safer and more pleasant. So thank you so much for being invited to the SAE Congress. I'm really delighted that I have been able to talk about the G35 committee. Now, do we have any questions on what I have presented?
Yes, thanks a lot for your presentation. I think we don't have any questions in the chat box yet. Interesting session on simulation and artificial intelligence, machine learning. That's the future which goes on. We have a question from Mr. Tamil Malar. Could you please repeat what would have to join the committee? You mentioned, okay, that's something asked. So I think one of us will help you on this, Mr. Tamil, and we will revert to you on that. So are you trying to open a link?
Yes. Yes, I was going to answer this question on how to join our committee. So it will take a few seconds, so please bear with me. If you do a quick Google search and type in SAE G35, you should be directed. Yes, we see already a link in the chat, and you should be able to open up this page that you will see in a second. So this is the page that you see if you are following the link. Now, if you scroll down to the very bottom, you see the link of Maureen. If you click there, you get her email address. And if you would like to get involved, please get in touch with Maureen, send her a message, and she will tell you what you need to do. You need to you need to do some small paperwork, and then you will granted access to this site, and as a result of this, you will be put on the roster where we have got all the registered participants already. So you will see yourself then in hopefully not too many days as part of this roster. And being part of this roster, you will be notified about the next meetings, which are also presented here. Yes, it's September 27. If you click on here, you will get some the information on the agenda and also the WebEx link for joining the actual virtual meeting. I hope that this answers your question on how to join this committee.
I think thanks a lot for your detailed explanation, Dr. Andreas.
Okay.
I think it's been a very informative session, and of course very futuristic, very interesting for most of the enthusiasts today. with this, I think we are at the end of the session 2, parallel session 2. Thank you, Dr. Andreas, for a session which is kind of very connected to what everybody is up to today: simulation, modeling, and machine learning and AI. So
Yes.
with that, I request all the participants and of course all the speakers as well to move to the session 1, where we have a wrap up of the day 1 proceedings. Once that is done, I think we will be able to also give an overview maybe on day 2, the agenda. I think you have it with all of you. So thanks a lot, and I have Satish Shastri, supporting the entire session here as co-host for us. Thank Mr. Suraj for maintaining the entire event of session 2. So with that, thanks to all speakers. See you at session 1 now. Thank you all.
Okay, thank you so much for having me. Bye-bye and take care.
Yes, you too. Bye.
Thank you. Bye.